Okay, so I had a brand iron stop working on me and thought I'd try to troubleshoot it to see if it was a bad iron that needed changed or maybe a cord or something was faulty. Got it taken apart and one of these wires was already broken off. It had lost singe marks and this one just was brittled. The other wire also had corrosion, but I had since cut it off before I decide, hey, this might make a good video to show. So I'm going to check resistance. You don't want to touch the outside like here and here. You want to touch the two inner wires here and here. So you can see it's moving the gauge. When I checked both ends of the wire out here, black and white, while it was attached, I was getting nothing. So now we're going to troubleshoot the power cord. Already got it off. Oop. I'm going to check if maybe it has a break somewhere in the cord that isn't quite visible. So we're going to grab both ends, stick one electrode in here, and then probe wire. That one's good. Black one is usually going to be the thinner of the two prongs here. On a three prong, you know, they're the same size, so you might just probe both white and black. Okay, now this one should be the white one. I'm getting nothing on that one. We'll double check if I got a bad connection. So I could have just had a power cord go out as well. Nothing there. What about the green one? Nothing there. I'll double check if this is working. Yep. So I also have a faulty cord. So connection here was already broken off. It may have been just something else causing it. There was heavy corrosion on this. Let me see if I can get a close up showing the bluing of the copper. I did think of just getting a new one, but I thought, well, I'll take it apart and see what I can come up with. There's a little machine screw that holds this all together. This is just a sleeve that they tighten down to hold all the heater elements in place. Essentially, it fits together like this. Yep. It's a tight fit, which is good. Let's see, it slides together. I don't have it all the way slid. So a little screw, one screw holds it all in place. Yeah, these cords go through some pretty severe duty. I mean, you can see where sometimes the irons hit this side of the cord. As I go along, there's actual fray that is showing now. It didn't get into the wires though. I was actually really looking at that earlier. Wires look fine there. It didn't hit the inside wires. But I bet you where this cord failed, right here when I looked at it closer. See, here's a burnt mark right here. So I bet you where the wire connects with this just burned through. I mean, this is high amperage. These get sometimes glowing red hot. I mean, these are for branding cows, so they have to do some burning there. So I thought of just repairing this end. I think I'm just going to opt, because locally I can buy new cords and do that route instead. As long as I match the gauge of this cord, I don't see it being an issue, and stick to a similar length. Because anytime you go longer in a cord, you need to actually go up in gauge thickness. And gauge thickness is the lower the number, the thicker the wire, the higher the number, the thinner the wire. So a 16 gauge would actually be thinner than like a 12 gauge wire. So I finally got some high temp crimps in, and they're actually built using nickel plated steel. They're supposed to be up till 900 degrees, I believe. Since this is heater electrode and I don't have anything to cut off really and re-splice, I'm going to use a Dremel with a carbide. And I'm going to very slowly take off enough. I mean, you see they wiggle a little bit. So once I, cut it off to be able to spread it, I'll be able to pull these off, put the new ones on, and go from there. Another thing to note is nickel can sometimes be pretty hard to grind through. So take your time. I'm far enough in. Looks like this was copper after all, but I frankly don't trust copper on a heated electrode. But that's all there is to it. And I didn't even wire up this surface, which is what I was worried about. So it's one way to take those off if you're worried about messing up the surface underneath. I also wanted to say something else here. What I'm grinding on is actually the crush side here. Let's see if I can get this down. It's a little hard to use a camera when you're trying to be in front here. See how it's crushed? The reason I'm doing that is these were oversized anyway, and I'm going to actually start to see the seam before I actually get into the underlaying electrode here. So it's just another little tip that I thought I'd pass along if you ever had to do something similar to this. Wanted to show you how you can start seeing the seam before you actually get into the electrode there. So just keep an eye on it and go slow. Alright, make sure to clean any of the dust out of here. You don't want the electricity to go on the outside of the burner here. And I thought I'd show you a close-up right here. Show you how cleanly that came off without, sorry about that. Without any nicks. I got one nick here, barely noticeable by the glaze. And one just passed because it grabbed, but not enough that this should interrupt the electricity flow capacity. So then when I get ready to attach the cord, I'll give you some more video on that. Alright, so apparently this didn't use high temperature wire, so I just matched the wires to the temperature range that was supposedly on the other cord. So they got little markings on the side of the cord for what type of duty they're supposed to be. At least this is how I was taught. I could be wrong. Always double check anybody's information. It says 60C on the side. That's what the old cord had said, so I went good enough for me. And it being a power tool cord had the same gauge, so just bought one of those, trim those off and make them work. Now, I know the old one was copper, but these are actually the high temp clips. They're nickel coated steel. They're meant to operate at 900 degrees Fahrenheit, well, up to, I should say. So these will work perfect for this. Right now, since I got to feed it through, get ourselves a bunch of excess here. Take this off. Green is ground on these. Put our screw back on. I'm not going to snug this up. I'm going to run it down and leave it loose. That way as I work with it, it allows this to move around so I can get my cutting distances right on these pigtails. So now, I'm going to have to clean this, so I got my electronic cleaner somewhere. There. It's right behind me. Electronic cleaner I'm using, safe on plastics and everything. I just like to make sure all the crud's out of there. It's okay to have a little slack. What I'm doing is kind of finding a place that's kind of a relaxed fit, and that's where I'm going to cut it. So I'd say right about like that. Give myself a little extra, so cut a little bit past. Like so. And the black one will go up to the high one. In this particular application, this is AC current. There is no converter, it just plugs right in. I do not see an issue with where these wires are going to go because the nature of AC. AC stands for alternating current. which means it goes between plus and minus in a wave. It actually passes 0 volts repeatedly over every second. And due to that going negative, positive, something like this wouldn't matter how you plugged it in. But again, check up your own sources, never take someone's word for things. There's a lot of false information out there. Heck, maybe I'm basing my own information off something false too. But that's how I've done things over the years and haven't had an issue. These wire strippers. The other good thing about using these nickel crimps, nickel steel crimps, is they don't transfer heat as well as like the copper type crimps. You also see them twisting these, helps get a better crimp. I recommend doing that. So then I have less heat transferring into the cord, so I don't get this again, which is what originally happened when it destroyed it. And look at that, just burned it off and corroded it away. So that shouldn't be a problem with these. Yep, grabbed the right size when I was online. I had to order these online. For some reason locally, one place sold them I found on their website locally, but the guy was too lazy to look it up. Not my problem, he lost business, so. Since these are steel, they're gonna take a lot more force to get to bend, to get to crimp, compared to some other styles of crimps out there, like aluminum or copper. And what I'm using on this, since this is a hard metal, so I'm using one of the spikes to really get a good punch on it. I'm just kind of going up. Make sure it's fully in there. I'm also aware of this seam on here too. I don't want to try to crimp on that little seam on these. So try to be aware of that when setting these in. So that way you're not putting the punch into that seam. That does not do you any favors of holding. Nice and tight. See it don't wiggle. It's on there solid. Again, I'm going to use the spike end for this. Also undo this because this is actually getting in my way now. But it was in long enough to get me set up. And that's all I was after with that for now. Alright, that's nice and tight. You can also crimp too tight and actually cause the butt splice here to cut your wire off. So be aware of that when you're crimping. To try not to apply too much force. This is going to be under quite a bit of heat, so I don't want to use any greases or anything, because it'll actually melt and then actually cause the opposite effect of stopping corrosion. It'll actually start wicking in dirt and moisture, because the dirt will get covered on all the melted grease. Alright. Almost got it. I mean, I'm that far with it, so that's good. Now, I'm waiting on some fiberglass tape, and I'll show you the rest of that once that's in. It's supposed to be here tomorrow. And that's what this insulator is supposed to be, because it's supposed to actually go in between here, like so. And then it gets wrapped in some fiberglass high temperature tape. I took a little test, made sure everything was out of the way. Look at that sucker. Now it's back in action and working great. So just ran it over, plugged it in temporarily. Just wanted to see if it got hot. Oh yeah. So, like I said, once I get my fiberglass tape, I can wrap this little section up here with it and put it back together. Alright, my high temperature tape finally came in. What I want to do first off is tape these right here. That way it's not trying to flex along where the crimp is and break these off after some time. So cut off a few small pieces here to use right here. Now some of this fiberglass tape is not meant for electrical, so be aware of that when you go to buy some. And they do have varying degrees of temperature, and usually it's the adhesive on it that's the limiting factor, not the actual fiberglass. Stuff that around there. There we are. There. I feel comfortable that it's going to stop a lot of the flexing right there. And you see this piece, we actually have a burn mark here. I'm going to clean that up because that can actually cause arcing later. So, see if I can find my sandpaper. Okay, now we'll be setting this in here. This is where this was originally. Wires are a bit twisted. There we go. It's about where it was. I like to give this a good wrap. I don't have my razor blade with me, but these work just fine. There we go. I want this nice and tight on this. This pulls everything together. Alright, I believe that should be good. That's how it was when I took it apart, so I have no reason to think that I should do anything different. Then we'll tighten up this screw down here. Put it all back together. You notice I'm actually taking this screw where I can bend this up because I want to keep this far away from here so this wire doesn't get burned. Alright, then we'll bend that clip just cautiously. I'm not going to tape this because I want this to stay apart. The hole isn't going to line up, so I'm going to shove this back through and turn this like so. See? Take my twist out. Doing this. Okay. Hole gonna line up? Yep. So what I'm doing is lining this hole up here to line it right here. So it's just easier for me to pull this way. Now I'm not going to pull hard. I'm just going to wiggle this as I push this in, work it, because I don't want to cause my wires to get bundled up in there and possibly burn. Like I said, that's going to be a tight fit, and I want to leave it a tight fit, since after all, it has to hold a lot of weight there. Actually, you know what works better is just twisting it on there, left and right a little bit. So it's nice and loose there. Start to see my hole. There. The hole's aligned. Bring it up close. And that's all there's to that. Since that's good, I'm going to go find my screw. It's a small screw, and I know I set it on a shelf here, so I'll be right back. So when I say I put it on a shelf, that was nice code word for saying I lost the screw. But I'd found a nice screw in some junk drawers, and it is the same size, just to show everyone how small of a screw really fit in there. I mean, that is just scrawny. So if you lose this, what I found is a light switch faceplate, one of those small ones like that, fit perfect. Well, there is multiple makers of these, so I wouldn't be surprised if this screw doesn't fit others, but this is what fit mine. This is a L&H electric brander. Get this snug. It doesn't need to be super hard because this is, you know, plastic glass type casing. And now we'll put our cord holder in. Again, you see our cord right here. Yeah, I think that'll give everybody a good view. So our cord comes in and it kind of does this. So looking at that piece, we want this tapered end on this to go in. Let's see if I get like so to the cord. See? Tapered in like so. We're going to push it in as much as we can by hand. I spun it a little bit. There we go. Alright, now we'll finish tapping it. See what I can get in there. I should have a punch light in here still. Adjust the camera angle for everybody. Make sure this don't spin. Just give it a slight tap slowly. This might not fit in there how I wanted it, but make it work. Checking our cord. Nope, a little more. I know this is about even, so we'll just pound it in until it's about even. As remember, this will actually cut the cord if you get too tight, so. And I'm not pounding that hard. It probably sounds like it, but I'm not. I'm just letting the hammer actually fall on the nail. Or punch. This is just old Navy. See, I seen the cord pick up a little bit, so I know I'm just into it. Now we'll give it just a slight bit more. There we go. I feel that's going to hold that good. It feels nice and tight. Alright, let's plug it in and see if it still functions after all that. I have no reason to believe it won't. No arcing. It's always a good sign. I want to move that piece of wood somewhere. Alright. Alright, so that piece of wood here. Gotta let this preheat. It's already getting hot. gonna wire brush some of this ash off of here while it's heating. Should be hot enough to burn. Not quite yet. It's getting there though. I have one little singe mark. Nope, that's barely. When you're doing branding, you're going to rock it anyway. It's just how these work. As you can see, it's picking up heat. It's always the wait to get these fully going. Once they're fully going, they work great. There we go. It's actually working like it did when it was new. See? Slight red glow. Actually, before this went bad, it actually stopped doing that. And that should have probably been my first clue something was up. I just figured it was getting old. So, might be your cord or connections in here going bad. If that starts happening to you, maybe take that as an early warning sign. See? Even started a little fire right away. So, working perfect. That's how you troubleshoot and possibly repair one of these branding irons.